Hello everyone, my name is Anusha Vachola. I'm going to present on performance validation for a successful Oracle Database 23 AI upgrade, along with best practices and a case study. We have Max, Zulia, and Sunil Kalra from United Airlines who are going to talk about their experiences with the upgrades and general change assessment strategy in their organization. Hope you can leverage the best practices presented by United Airlines to reduce the time to test and get on to the new releases and adopt technology changes. Today's agenda is as follows. We examine database upgrade challenges. How do we prepare for Oracle Database 23 AI upgrade? And how do we validate performance of 23 AI before going live? Also, we will present United Airlines case study, as I have mentioned earlier. Database upgrade challenges. We all want to know what init.ora parameters have changed in Oracle DB 23 AI from my current release, and how it will impact database and SQL performances. We want to be proactive and perform load and throughput testing before deploying the upgrade in the production. We want to test beforehand and be prepared for any unforeseen situations. Hence, one wants to test the upgrade and validate the performance of the upgrade. Before we discuss the upgrade and performance, let's understand the upgrade path, current version of the database and the destination of the upgrade, that is 23 AI. Here, there are two possible upgrade paths. One is from the older versions, that is 11G to 18C, a double hop upgrade to 19C and then to 23 AI. Second path is from 19C or 21C to 23 AI database version. Let's see the lifetime support of these database versions. If you notice, 19C is in waived extension phase and 21C is till 2025. Sooner or later, we must upgrade to 23 AI before the updates of the older versions are not available anymore. Besides, 23 AI has latest and exciting feature which one wants to explore, such as AI vector search, JSON relational duality views, etc. To know what are the new changes in the latest version, we have OraDiff tool, which lists the added, removed, or modified parameters or objects, etc. Now we have seen the upgrade paths and the changes in 23 AI. There are few best practices to ensure the smooth upgrade. 23 AI is a multi-tenant, so ensure that you're converting your non-multi-tenant database to multi-tenant. Use migration workbench to accomplish this, which is a real application testing functionality. Remap all the connection to the respective PDBs. Ensure client connectivity is in place. Sometimes connect string needs to be upgraded too. Perform a dictionary or health check prior to the upgrade. Gather optimizer statistic to avoid potential downtime. Upgrade needs to be tested on the test or the cloned database. Have the test system resources such as CPUs or IO bandwidth similar to production and have an appropriate backup strategy. Let's now look into how do we validate the performance of the database during the upgrade. For that, we have real application testing as a solution. We have many components and we focus on two in this presentation in the interest of time. SQL Performance Analyzer, which is commonly referred as PA, and Database Replay. In this session, we are going to cover SQL Performance Analyzer. It will allow us to proactively identify regressed SQLs before the change is applied and tells us how to improve or fix the regressed statements so the upgrade is smooth. Before we explore how to use SQL Performance Analyzer, we must ensure we establish a performance baseline. As I've mentioned in my earlier slides about having the test database, that is clone of the production database, we need to also make sure that we are testing the upgrade on a significant workload that is captured into a SQL tuning set. Make sure that the SQL tuning set is transported to the test system where we are going to run SPA. There are few limitations to be aware that we do not support PL SQLs. SQL Performance Analyzer. What are the key capabilities of SPA? As we see here, it takes SQL tuning set as an input, which contains SQL statements, real production execution context, binds, and optimizer settings, etc. It built two trials. One without the change, that is pre-change trial, is the baseline, and other is with the change, that is post-change trial. And it also helps in identifying the impact of system changes between the first and the second trial. It generates the report to help us find and remediate the regressed SQL. It is also integrated with the best practices, which I will be showcasing in the demo as well. The benefits we get out of SPA are automated and reduced time to test using real workload SQL and the context. You don't need to manually capture the binds, SQLs, etc., as capturing the SQL is real easy. It automatically remediates SQL regression by a click of a button to improve the application quality of service. And all of this is to maintain and improve the SLAs. Overall steps, this is just a pictorial understanding of the steps. First step is to create the STS, then you have pre-change trial, which is with the baseline setting. Then you make changes, that would be post-change trial. Compare both the trials, which is to compare also the performance of both the trials. As it generates a detailed report, we can analyze the report. If you find something that is concerning or regressed, then probably we have to tune the regressed SQLs, then tune the SQL and implement the recommendations. You can go back and rerun with these recommendations to assess the performance now. You can have multiple post-change trial to compare it with the pre-change trial. In this demo, I'm going to proactively assess the impact of Oracle database upgrade, let's say 19C database to a high version of the database, that is 23AI. So for the purpose of this demo, I have copied 19C database to a different host. Let's start testing the upgrade by creating a SPA task and choosing the workload, that is SQL tuning set. Ensure the user has sufficient privileges to run the task, or you can create a SQL tuning set by clicking on the Create button here. As this is an upgrade scenario, I'm going to choose Upgrade from the drop-down menu of Change Type menu. Basic is with the recommended settings, whereas Advanced Creation Type is used to customize the task. As I've mentioned, I have 19C on another machine. I'm going to run pre-change trial remotely by using the DB link. You can also create the DB link by entering service name and credentials to connect here. Since my 23AI is on the same server as orchestration database, I am going to run post-change trial locally. Choose the comparison metric of your preference. You can schedule the task or run it immediately. Let me submit the task. We could see the status of the task is changing from processing to complete. It's now running for post-change trial, and then it will compare pre-change trial and post-change trial. Let's look at the task results and comparison report of elapsed time. There is an increase in elapsed time for before and after the upgrade. The report is regressed. Let's pick the most or top regressed SQLs. We can investigate each metric such as CPU time, buffer gets, number of execution, etc. in this section. There is a plan change for the SQL statement. The plan before, that is the plan in the pre-change trial, was using an index scan, whereas the post-change trial is using a full table scan, hence the SQL is regressed. I'm going to create a SQL tuning set with all the regressed SQLs and run SQL Tuning Advisor. Let's implement it and rerun the trials. I'm implementing SQL profile of only one of the SQL which we picked earlier in the interest of time. I'm going to create a new trial with implemented SQL profile recommendation and have a new comparison with these changes. Let's look at the results now. There is an improvement in the elapsed time for the same SQL ID which we tuned. Also, the entire workload is performing much better since the tuned query is performing better. Let's move on to the United Airlines case study. I'll let Sunil and Max take over from here.
I am Max Zoya, Senior Manager at United Airlines, the best airline in the world where good leads the way.
Hi, this is Sunil. I'm working as a principal DBA United Airlines for the last 15 years, handling their mission critical databases. So at United Airlines is one of the leading airlines of the world. Worldwide, we fly more than 500,000 passengers every day. Any small hiccups to the system performance or availabilities results in a widespread delays, ground stops, and loss of millions of dollars in revenue. At United, we have 500 plus production, non-production Oracle databases. These databases range anywhere from 5 GB to 50 terabyte in sizes. These are the various mission critical databases critical for the operation and revenue applications. Thousands of the SQL statements with a sub-second response time running in this environment. So any latencies play a big role in defining a successful operation. For any environment like this, upgrade and migrations are always a big challenge. In any system, it is hard to predict the workload, how the workload would behave in the new environment, whether it is a platform migration, database upgrade between the major or minor releases. There is always a question mark whether system will improve or regress. At the same time, it becomes very hard to sell out the application to the application folks without key metric data about the performance improvement. At United, we have workload of numerous complex queries. The kind of business model United has, there are multiple time frames in a day with a varied workload, like a peak travel hours, rush hour like morning and evenings, slack time like afternoons, and late night where all the batch activity happens. At the same time, schedules offload work, maintenance activity, backups, all these performance of all these are very critical for the next day operation also. All these should be addressed thoroughly from the performance perspective for any other migration or upgrade effort. And these are the main challenges for us too. With the introduction of SPA, SQL Performance Analyzer, a real application performance testing tool, it has made our life somewhat easier from the perspective that we can assess and predict the change in the behavior of these SQL workloads during migration and upgrade efforts. At United, we have adopted it as our preferred tool for any performance testing during these complex migrations and upgrades. We extensively use and stress on the using SPA on mission critical databases during upgrade and platform migrations. With that testing, we can confidently predict system performance post upgrade migrations and confidently present and justify the results to the application folks to get their commitments for these efforts. One of the key elements in comparing system performance with the new system is having a comparable workload of the SQL statement volume of data. At United, we prepare any DB upgrade migration. We prefer to build a parallel environment with a continuous replication between source and the target, pre-production and production. That gives a couple of benefits like testing performance in a real time when it is ingesting data and same volumes like production. Same structure of the data structure like a current production. At the same time, it helps in a shorter outage windows. And changes can be reversed easily also. To avoid all these constraints, we use the real-time replication methodology. During the outage window, we just stop the replication, switch the GTM, load balancer URL, and start the reverse. This app also results in quicker fallback in case it needs to be, although nobody likes to fall back. In this whole process, there is no change for the application for any configuration at the application layer. During the whole build and prepare phase, we are able to test and verify the performance as many times as we wanted. We capture a good sample of SQL training sets, and using the SPA framework, we ran the workload to produce the detailed comparison report to us. We can use the EM framework or develop SQL statements to perform end-to-end activity. I personally started with EM and then switched to the backend when we started dealing with 3,000, 4,000 sample of SQL statement workload. So once you run the SPA, it produces a nice graphical analysis of the workload comparison. If we look at the report, it shows how big was your workload in terms of the statements. The report was run against, like in this report, it was run against the 700 plus SQL statements. Some of our workloads ranges in 2,000 to 10,000 SQL statements. The first histogram shows the collective elapsed time of the SQL training set versus if it would run in the new system. This is a good indication of overall workload comparison between the two systems. Next one shows how aggregate of the SQL statement by performance, how many improved, how many there is no change, and how many regressed. Next two basically shows how many SQL statements change. There's a change in the plan and how many SQL systems errored out. You can, going back to the SQL statement by performance, there is a detailed analysis for every SQL statement, how it is performing in the new system, whether there is a plan change, net impact of the SQL, what is the elapsed time of the current SQL statement versus what it would have been when it goes to the new system. You can drill down by clicking the SQL ID, then display detailed statement where it shows the bind variables being used. It also displays the breakdown of the time spent in the SQL execution in terms of IOs, buffer gets, CPUs, and the cost, and present a graphical comparison of both the SQL statements. Like in this detailed analysis of this statement execution, although it does show there's a little higher reads, close to 5% higher, but overall user IOs are improved. And it is expected to take 63 milliseconds compared to 400 milliseconds. The case we presented here is where we did not find any regression, but there are many instances in the past where when we are migrating from 12 to 19, we found some statements regressed. In those cases, when we running near parallel system in terms of the volume, we are able to run the SQL Training Advisor and implemented the recommendation and retested and verified. For us, it is a great tool working out very well for any DB upgrades and migrations.
We use incremental cursor cache capture of the SQL tuning set to avoid overhead on the production systems. We run the workloads in production during the maintenance windows. We don't just focus on activities during peak time, but we also focus on activities where various maintenance jobs run or batch jobs. Successful, timely completion of these could also be crucial to your next day's operations. While running in test, make sure it has comparable configurations in terms of SGA and PGA or optimizer settings and other parameters. Some of your main parameters would be SGA max size, SGA target, open cursors. PGA limit is more recently added. parameter and optimize our adaptive plans, which has impacted us in the past. We use several runs and several metrics to compare like elapsed time, CPU time, pre and post. With that, we conclude this presentation. Anusha, back to you.
Thanks, Sunil and Max, for giving us details of SQL Performance Analyzer usage at United Airlines. I hope everyone got insights of how to validate performance before the upgrade. Thank you all for joining this session.